this video, we're going to look at how to find the derivative of f using the limit definition. So we all know that this is the limit definition to find f prime, in other words, the derivative of f given by this definition, assuming that the limit exists. So let's go ahead and see if we can do an example finding the derivative using this limit definition. We want to find f prime of x using the limit definition. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So we need to figure out what this is, and we know this is f of x. Subtract them and divide by h, then take the limit. So let's go ahead and do that. So we know the limit as h approaches 0. F of x plus h just means you insert x plus h into this input and this input, meaning everywhere there is x in the function, replace it with x plus h. So we have f of x plus h will be x plus h squared minus 3 times x, so x plus h plus 4. So that's my expression for f of x plus h minus f of x, that's the original function, x squared minus 3x plus 4. Now I'm putting brackets around so that way we're very careful how we're making the substitution. Now for the first bracket term, we can expand. So we have the limit as h approaches 0. So here, if I expand this x plus h squared, that's simply x plus h times x plus h, which would be x squared plus 2xh plus h squared. For the second term, we distribute this negative 3 out. So that's negative 3x minus 3h and plus 4. For the last terms, the terms in the brackets, we just need to distribute the negative out. There's nothing to expand. So that's minus x squared plus 3x minus 4, everything over h. Now a lot of things will cancel out right here. So note that x squared, negative x squared cancels out. And then negative 3x cancels out. And 4, negative 4 cancels out. So what we're left with is something very nice. So you have the limit as h approaches 0. We're left with 2xh. Let me rewrite that. Plus h squared minus 3h all over h. Now here we can simplify this a little bit more. Note that every term on the numerator has h in them. So I can simply factor out an h. That gives me 2x plus h minus 3 all over h. Now here we should notice that h cancels out. So then now we have the limit as h approaches 0 of 2x plus h minus 3. Now if we take the limit, substitute h equals 0, you have 2x plus 0 minus 3, which gives us 2x minus 3. So that is our f prime of x. So that's the derivative function of this given function.